Hello grade 9 students. Today we will continue our lesson Electrochemistry Part 4. At the end of this video, you will be able to identify oxidation-reduction reaction based on the variation of the oxidation number, identify oxidizing and reducing agent in a redox reaction. Before we start, it's better to recall some information. Identify the substance that is oxidized and reduced in the following reaction. Mg plus 2Ag plus give Mg2 plus 2Ag. As you see here, Mg loses 2 electrons to become Mg2 plus, so it undergoes oxidation half reaction, then Mg is the oxidized species. As we said, because Mg undergoes oxidation half reaction, so we can write the oxidation half reaction as Mg gives Mg2 plus 2 electrons, whereas Ag plus gains 1 electron to become Ag, so it undergoes reduction half reaction. Then Ag plus is the reduced species, and because Ag plus undergoes reduction half reaction, we can represent this by an equation Ag plus 1 electron gives Ag. Now, how does the oxidation number of species vary in oxidation and reduction half reactions? Oxidation number of Mg, because it's a free element, it's equal to 0 as we said. And the oxidation number of Mg2 plus, because it's a monoatomic ion, its oxidation number is equal to the charge of this ion, which is plus 2. So, in an oxidation half reaction, as you can see, the oxidation number was 0, then it becomes plus 2, so the oxidation number in a oxidation half reaction increases. So in oxidation half reaction, the oxidation number increases. Whereas here, the Ag plus, the oxidation number of Ag plus, because it's a monoatomic ion, it's equal to the charge of this ion, which is plus 1. And the oxidation number of Ag, because it's a free element, its oxidation number is equal to 0. So as you can see here, the oxidation number was plus 1, then it decreases to become 0. So in reduction half reaction, the oxidation number decreases. In an oxidation reduction reaction, there is a change in the oxidation number of the reactants. An oxidation occurs when the oxidation number of an element increases, while a reduction occurs when the oxidation number of an element decreases. Here, Mg plus 2Ag plus give Mg2 plus 2Ag. As you can see, the oxidation number of Mg, as we said, is 0, Ag plus 1, Mg2 plus 2, and Ag is 0. So the oxidation number of Mg, it was 0, then it increases to become plus 2. Thus, Mg undergoes oxidation half reaction, whereas the oxidation number of Ag plus was plus 1. It decreases to become 0, thus Ag undergoes reduction half reaction. The oxidizing agent is Ag plus since it undergoes reduction half reaction, whereas the reducing agent is Mg since it undergoes oxidation half reaction. Now, are all reactions redox reactions? How can we tell if the reaction is redox reaction? By the variation of the oxidation number. If the oxidation number of elements doesn't vary, doesn't change, it remains constant, then the reaction is not redox reaction. Whereas if the oxidation number of elements varies, increases and decreases, then the reaction is said to be redox reaction. Application 1. Indicate if the following equation corresponds to a redox reaction or not and justify your answer. 2H2O gives 2H2 plus O2. So prepare a pen and a copybook, pause the video, try to solve this reaction, then follow us within the correction. First of all, we should assign the oxidation number of each element in the reactant and in the product. To start with 2H2O, so we take H2O and we should not take into consideration this coefficient 2. H2O, as we said in the previous video, we are interested to know the oxidation number of the atom that is inside the compound, only the atom. So here we don't take H2, we only take the oxidation number of H. So the oxidation number of H, because as we said also in the previous videos, oxidation number of hydrogen in a compound is always equal to +1, and the oxidation number of oxygen in a compound is always equal to -2. In H2, we don't take into consideration the coefficient as we said, and we are interested in taking the oxidation number of an atom only. So here we said that the oxidation number of H and not H2, the oxidation number of H in H2 is 0 because it's an element, and the same case in oxygen O2, we are interested in taking into consideration only atom, يعني we are calculating or determining the oxidation number of O in oxygen. It's equal to 0 because also it's a free element. So the oxidation number of H in H2O is equal to +1, O is equal to -2, H in H2 is 0, and O in O2 is 0. As you can see here, the oxidation number of H decreases from +1 to 0. Thus, H undergoes reduction half reaction, whereas the oxidation number of oxygen increases from -2 to 0. Thus, O undergoes oxidation. So, this reaction 1 is made up of oxidation and reduction half reactions. So, then this reaction is a redox reaction. You should take into consideration, شباب and صبايا, that each sentence that I wrote, you will take marks on it. Any missed information, the teacher will give you minus on this part. Application number 2. Indicate if the following equation corresponds to a redox reaction or not and justify your answer. AgNO3 plus KCl give AgCl plus KNO3. You have given, knowing that in a compound, the oxidation number of Ag equal to +1 and the oxidation number of K equal to +1 also. So, let's start with calculating the oxidation number of each atom constituting each compound alone. You have given that the oxidation number of Ag is equal to +1. You know that the oxidation number of oxygen in a compound equal to -2, but you don't know the oxidation number of nitrogen in a compound, so we should calculate it. The oxidation number of nitrogen in AgNO3 is equal to the summation of each element times the number of atoms equal to 0, because the summation of oxidation number of all the elements constituting a compound is equal to 0. Then the summation of the oxidation number of Ag plus the oxidation number of N plus the oxidation number of O. Here Ag is only one atom, so times 1, N only one atom times also 1. Here oxygen, there are 3 atoms, so times 3, all are equal to 0. We substitute oxidation number of Ag to +1. Oxidation number of nitrogen is unknown. We substitute the oxidation number of oxygen within -2, so 3 times -2 equal to 0. The oxidation number of nitrogen equal to +5, and please don't forget that at the end of the calculating the oxidation number, you should put the oxidation number in Romans. So oxidation number of nitrogen equal to +5. So you can write now +5. The oxidation number of potassium is given +1, but we don't know the oxidation number of chlorine in a compound. So let's calculate it. The oxidation number of chlorine in KCl is equal to the oxidation number of potassium plus oxidation number of chlorine, all are equal to 0. Oxidation number of potassium is equal to plus 1 plus oxidation number of chlorine equal to 0. So the oxidation number of chlorine equal to minus 1. Now we can put minus 1. In a compound, we know that the oxidation number of Ag is equal to plus 1, but we don't know the oxidation number of chlorine in a compound. هلا بيجي حدا بيقول لي but we calculated يا teacher here انه the oxidation number of chlorine is minus 1. Any oxidation number of any element that you didn't take it as a study, يعني this means that its oxidation number varies. يعني انتو you take to study مثلا the oxidation number of oxygen in a compound is minus 2. So oxygen in any compound is equal to minus 2 its oxidation number. Whereas you didn't take to study chlorine or nitrogen. So this means that in each compound their oxidation number varies. So let's now calculate the oxidation number of chlorine in AgCl. Is equal to the oxidation number of Ag plus oxidation number of chlorine are equal to 0. Oxidation number of Ag equal to plus 1 plus oxidation number of chlorine all equal to 0. So the oxidation number of chlorine equal to minus 1. We can substitute now with minus 1. The oxidation number of potassium equal to plus 1. The oxidation number of oxygen is equal to minus 2. Then we want to calculate the oxidation number of nitrogen, which is vary in each compound, even though we calculated here. The oxidation number of nitrogen in KNO3, oxidation number of potassium plus oxidation number of nitrogen plus 3 oxidation number of oxygen. We know that here we have only 1 potassium, here 1 nitrogen, here 3 oxygen. Because of that, we times or multiply with 3, all equal to 0. So plus 1 plus oxidation number of nitrogen plus 3 times minus 2 equal to 0. So the oxidation number of nitrogen is equal to plus 5 in Roman. So we calculated all the oxidation number of all the atoms in this reaction. As you can see here, the oxidation number of Ag was plus 1 and remains plus 1. The oxidation number of nitrogen was plus 5 and remains plus 5. The oxidation number of oxygen was minus 2 and remains minus 2. The oxidation number of potassium was plus 1 and remains plus 1. The oxidation number of chlorine was minus 1 and remains minus 1. So you can conclude that since the oxidation numbers of all the species in the reaction to change, so this reaction is not a redox reaction. Application number 3. Consider the following redox reaction. Mg plus O2 gives 2 MgO. Identify the species that undergoes oxidation half reaction and the other that undergoes reduction half reaction. You should take into consideration that the verb identify is an action verb that needs justification. So now I should justify which species undergoes oxidation half reaction and which species undergoes reduction half reaction using the oxidation number. Mg plus O2 gives 2 MgO. The oxidation number of Mg, because it's a free element, is equal to 0. The oxidation number of oxygen in O2 is also equal to 0 because it's a free element. The oxidation number of O in a compound is always equal to minus 2. Then we want to calculate the oxidation number of Mg in the compound. The summation of the oxidation number of each element times the number of atoms equal to 0. Oxidation number of Mg plus oxidation number of O equal to 0. Oxidation number of Mg plus minus 2 equal to 0. Thus, the oxidation number of Mg equal to plus 2. So we can put plus 2. As you can see here, the oxidation number of Mg increases from 0 to plus 2. So this means that Mg undergoes oxidation half reaction, whereas the oxidation number of oxygen decreases from 0 to minus 2. So oxygen undergoes reduction half reaction. So now deduce the oxidizing agent. As we said that Mg undergoes oxidation half reaction and O2 undergoes reduction half reaction. So since O in O2 undergoes reduction half reaction and the oxidizing agent is the species that undergoes reduction half reaction, then O2 is the oxidizing agent. Please, each sentence written here, you should take on it marks, and any missed information, you will lose marks. Deduce now the reducing agent. So the reducing agent is the species that undergoes oxidation half reaction. So here G undergoes oxidation half reaction, and here I took marks. And the reducing agent is the species that undergoes oxidation half reaction. Come in, and I took marks here. Then G is the reducing agent. So please don't miss any information, because verb deduce is an action verb that needs justification. So you can't say only G undergoes oxidation half reaction, so it's the reducing agent. You should say that because the species that undergoes oxidation half reaction is said to be reducing agent, so G is the reducing agent. Application number 4 now. Number 1, show that the following reaction is a redox reaction. Identify the oxidizing agent. Write the oxidation and reduction half reactions. Let's start with number 1. Show that the following reaction is a redox reaction. 4Fe plus 3O2 give 2Fe2O3. The oxidation number of Fe, because it's a free element, is equal to 0. The oxidation number of oxygen also is equal to 0 because it's a free element. The oxidation number of oxygen in a compound is always equal to -2. Now we want to calculate the oxidation number of Fe in Fe2O3. As I said, we don't take into consideration the coefficient here, number 2. Yani I should erase it within my mind. Now, the summation of the oxidation number of each element times the number of atoms is equal to 0. So the oxidation number of Fe plus the oxidation number of O is equal to 0. Here, how many Fe atoms you have? 2, so times 2. And how many oxygen atoms we have? 3, so times 3. So we take into consideration the subscripts, and we don't take into consideration the coefficient. So 2 oxidation number of Fe plus 3 oxidation number of -2 is equal to 0. 2 oxidation number of Fe minus 6 equal to 0. 2 oxidation number of Fe equal to plus 6. Oxidation number of Fe equal plus 6 over 2 is equal to plus 3. So as you can see here, the oxidation number of Fe increases from 0 to plus 3. So Fe undergoes oxidation half reaction, while the oxidation number of oxygen decreases from 0 to -2. So oxygen in O2 undergoes reduction half reaction. This reaction is made up of oxidation and reduction. Thus, this reaction is a redox reaction. Number 2, identify the oxidizing agent, knowing that Fe undergoes oxidation half reaction and O2 undergoes reduction half reaction. So first of all, oxidizing agent is the species that undergoes reduction half reaction. So I say that oxygen undergoes half reaction, and the species that undergoes reduction half reaction is said to be oxidizing agent. So oxygen is the oxidizing agent. Number 3, write the oxidation and reduction half reactions. We have, these are the given. First, the oxidation half reaction is, here we know that Fe is a ferric ion and not ferrous, because Fe it's a 3 plus. Why? Because the subscript of O is a 3. So here Fe was Fe3 plus. So Fe gives Fe3 plus 3 electrons. Here the reduction half reaction, the oxygen is O2 minus, because the subscript of Fe is 2. So oxygen was O2 minus. Oxygen plus 4 electrons give 2O2 minus. As a summary that you should not forget, oxidation is the reaction during which the oxidation number of reactant increases. Reduction is the reaction during which the oxidation number of reactant decreases. Reductant or reducing agent is the species that undergoes oxidation reaction. Oxidant or oxidizing agent is the species that undergoes reduction reaction. The species which is oxidized is the one which undergoes oxidation. The species which is reduced is the one which undergoes reduction.